Okay, guys, so we are starting chapter 4, 4-1, graphing systems of equations. Okay, so systems of equations. What is a system? A system is when you're solving more than one equation at a time. You can be solving two equations at the same time, three equations, four equations, five equations, but don't worry, this is the first time you're doing it, so you're only solving two equations at this time, only two equations. All right, so the way we're going to solve them in this lesson is by graphing them together. They're going to go together in the same graph. So let's solve these two. You have y equals 1/2 x minus 2, and over here you have y equals 3x minus 7. So I'm going to make my graph. And since they're negatives for the starting points, I'm actually going to make my graph more on the negative side. 1, 2, 3, 4, 5, 6, 7. Sorry, I wish I could give you all graphing paper, but just do the best you can. All right, so we're going to graph this. I'm going to use two different colors. So I'm going to use green for this one. So I'm going to graph this one first, starting at -2. So your y-intercept is -2. Your slope is 1/2. So we go up 1/2. You can do it a couple times, up 1/2. And your line will look something like this. If you have a ruler, I recommend using a ruler just to keep your line straight, but if not, just eyeball it. Okay. This one starts at -7. I'm going to do this one in red, starting at -7. 1, 2, 3, 4, 5, 6, 7, right here, -7. Now this slope is 3. So when your slope is a whole number, don't forget, just put it over 1. So your slope is up 3 over 1. So 1, 2, 3 over 1. Do it a couple times. 1, 2, 3 over 1. Draw your line. Okay, so you just graphed two lines on the same graph. How did I solve it? Well, guys, solving systems means you're looking for where the systems are the same. Or in other words, where do they intersect? Where do they cross? So guys, your answer is right there. This is your answer. This coordinate. So this x and this y, in this case, would be x is 2, y is -1. Guys, this is your answer for these two equations. This is your answer for the system. Your answer for x and your answer for y. And this is basically it. When you're solving a system of equations, you intersect where the lines touch, where they cross, that point is where you find your answer. That is where the graphs are the same. So this is the basic idea right here, okay? Now, this one worked out pretty well. I can see it pretty clearly that they intersect. When you graph it by hand, you're going to have to estimate sometimes, especially because you're doing it by hand. So you're going to see, okay, I'm not exactly sure what point that is. In those cases, guys, just estimate. So when you're doing the homework and it comes out wrong, it's fine. You're trying to figure it out the best you can using freehand. If you had graph paper, I would be more picky, but I understand we're kind of working with whatever we have. So just try to find the closest spot to where you think they're actually going to cross, okay? All right, let's do another example right here, okay? Make another graph. Now, these I notice are on the positive side, so I'm gonna make my graphs more on the positive side. So you're free to kind of not necessarily make them all the same, okay? And already I don't like the way I did this, but too bad. I gotta work with what I got. Okay. See, I should get a ruler, but I think they're all at school. I don't think I have any rulers in my house. Okay, so I think this is gonna be one where I estimate. I'm gonna try my best to estimate this answer. All right, starting with this one, slope is 10. Oh, sorry, not the slope, the y-intercept, the b. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The slope is 2x. So again, I have a whole number, so I'll make it 2 over 1. So it goes up 2 over 1. Now this is where it's going to get a little tricky. This line is going up like this. But down here, what can I do? Well, guys, if there's something you can do, if you're going up 2 over 1, you can actually follow the same kind of steps backwards. So go over 1 and down 2. And it keeps the slopes the same. So if you kind of go backwards using the slope, you can graph in the other direction. And that's another way to kind of keep your line straight, especially if you're going to have to estimate where your lines cross. Okay. All right, the other line starts at +1. But my slope is -1/4. So this case, when it's a negative, it's going to go down and to the right. So I'm not going backwards. The slope is negative, so it goes down and 4 spaces this way. Down and 4 spaces this way. But you know what? I kind of do have to go backwards because it's not going to cross over here. It's going to cross over there. So again, you could use the slope, but go in this direction. So I'm going to go 4 this way. 1, 2, 3, 4. And up 1. So I'm still following the same slope, but just backwards. Okay. So I think I found my intersection. My answer is right here. Now, again, I said I did this freehand, so I'm going to have to guess what my answer is. So I'm going to guess that my x is 1, 2, 3. -4 is my x. 2. I think 2 is my y. So my answer for this, I assume, is -4, 2. That's my answer for x. This is my answer for y. Okay. Now we'll get into how we use these in the equations next time. For right now, we're just finding the intercept. All right. Let's go on to the next example. Okay. Now this is where we get into a little bit of a complication. This one I can graph, ladies and gentlemen. I cannot graph this one. So there are cases where you're going to have to do a little bit of algebra before you can graph your answer. All right. So remember, to graph these, the easiest way to graph these is to turn this into slope-intercept. We want to make them look like this: y equals mx plus b. Because we want it to match the way this one looks for graphing purposes. Okay. So that means we need to solve for y. So the y needs to be the only term there. So we're going to use inverse operations. I'm going to cancel out the -4x. That's gone. Now I'm going to put the -4x first because I want it to look like this. And the slope with the x is the first term there. Okay, next, that -8. I need to get rid of that -8. But this number is not subtracting y. This number is multiplying. So I'm going to divide to get rid of that -8. So if I divide, you have to divide every term by -8. That'll leave me with y, a positive. Now you should simplify this. Don't turn into a decimal because you're going to graph. So don't turn these into decimals. So this is different from chapter 4. Simplify it. Half. I divided both numbers by -4. 4 over 8 is 1/2. Negative divided by negative is positive. And ooh, this is going to be a fraction. -1 and 1/2. Okay, so see, this is going to be where it's going to be a little interesting to graph because you're going to have to estimate 1.5 when we're doing our y-intercept. All right, but now, guys, we're ready to go. We're ready to graph this. So this one's on the positive side. This one's on the negative side. So I'm going to try to do this, but it's only a -1. So I'm going to try to stick more on the positive side. Try to use the lines to help you keep it straight. I'm going to start with this one. Positive 7. Up 1 over 2. Up 1 over 2. Up 1 over 2. My line looks like that. It's probably going to be that way somewhere. Okay, this one, the one I was solving for here, this is starting at negative 1.5. So negative 1, negative 2, in between these two. In between. Up 1 over 2. Wait a minute. Up 1 over 2. Oh, they have the same slope. Okay. Guys, when they have the same slope, this is what we call parallel. And guys, when lines are parallel, they will never cross. They will never cross. And if the whole point of graphing is to find out where these lines meet, when you have parallel lines, they're never going to do that. So this is a no solution. These lines will never cross. They will never be equal. Okay? So that's the case there. So actually I should have realized that here. Once I saw these slopes were the same, but these points were different, I should have known they were going to be parallel lines. All right, let's do one more like this where we have to change it. Okay. Ooh, there's two here that we have to change. So we have to change both of them. Okay. Let's do some work here. Sorry. Use 1.5 there. Yes. But remember, when you graph, you're going to want to turn it, if it's slope, you're going to want to turn that decimal into a fraction. Okay. I'm going to try to do this one quickly. So I apologize if I'm not going to talk through every step here. But it's the same steps that I did in the other one. I'm moving the term with x and I'm dividing by 2. So I get this slope, and that would be 4.5. Okay. So that's my line here. This line, I have to get rid of this. Oh, that's only one step. I have to get rid of this. So this is important. If you want to get rid of a fraction, ladies and gentlemen, we use the reciprocal. I'm going to multiply the opposite fraction 3/2. That'll cancel it out. But then that means I need to multiply 3/2 times both of these. So both of these are going to multiply by 3 over 2. So 3 times 3 over 2 and x times 3 over 2. I'm going to get something that looks like this. I don't like that order, so I'm going to flip it around. The slope goes first, and then this would be, oh, wait a minute. My two different equations here, when I changed them, just became identical. What just happened? Well, here's what happens if I graph them. Okay? Here's what this looks like if I graph it. I'm going to start at 4.5. 1, 2, 3, 4.5. Down 3. 1, 2, 3, over 2. Okay, there's my line. There's my first graph for the first line. Here, 4.5. 1, 2, 3, 4.5. Negative 3 over 2. 1, 2, 3 over 2. There's my second line. Okay, if you notice, they are in exactly the same spot. So we call this coinciding lines. These lines coincide. What does that mean? It means that they are basically on top of each other. They are connected. Every point is a point that is connected to the other line. So guys, this is not a no solution. This is many solutions or infinite solutions. So infinitely many, infinite solutions. Sometimes you see the phrase all real numbers, but That's what happens here. Every single point is a point where these lines are connected. Okay, the last two, just so that I don't go over time, are how to use these in Desmos. So guys, for these problems, we're going to talk about them, but then we're going to use Desmos to solve them. So you have a tool to check that. Oh, there's some questions in the chat. Give me a second. Let me open up those questions. Okay.
It's okay. I found the answer, Mr. Morales.
Okay. Thank you. So, here we go. Monica and Mary have 2 weeks to read the same 220-page novel. Okay, so they're reading a book that's 220 pages. Monica is on page 96. Mary is on page 6. Okay, if you can guess, since we're using linear equations, this is our starting points. These are the y-intercepts. Monica is reading 9 pages a day, and Mary plans to read 20 pages a day. Pages per day, 20 pages per day. This will be our slopes. We are going to write linear equations for both of them. So I wish I would have chosen 2 names besides Mary and Monica, but since I didn't, I'm just going to have to identify them differently. So we'll make Monica 9 pages. That's her slope, and she left off on page 96. So this is Monica's equation. Y equals 9x plus 96. For Mary, she's way behind, but she's planning to catch up by reading 20 pages a day. Good luck to her. I don't think I could do that anymore. That's too many pages for me. Okay, so these are the 2 equations that represent how fast they're reading. The question is, who will finish the novel first? They have 2 weeks, so we're talking about 14 days. So this is 14 days to finish it. So first of all, will they be able to finish it? And if they do, who's going to finish it first? So how are we going to use Desmos to do that? So I'm going to open up Desmos real quick. I'm going to show you how to put in these equations to solve it, okay? So you guys can also open up Desmos, but what we're going to open up is going to be the Desmos graphing calculator. So not the scientific, not the one with a line of regression. We're not using those. The graphing calculator. So the one that looks like this. Now, here's how we're going to use it. We're going to enter both equations that you created.
I can't see the screen, Mr. Morales.
Oh, thank you very much. I need to share it with everyone. All right. This one, guys, desmos.com/calculator. So you just enter them exactly as we wrote it down. Y equals 9x plus 96. So this is going to be Monica's. And then hit the next space to make another equation. Y equals 20x plus 6. Okay, now, you can't see them, right? So we're going to zoom out. And actually, I'm going to change some of the settings here. Because this is only for 2 weeks, I'm going to make this from 0 days to 2 weeks. Let's go 14 days. And then for the y-axis, since we're doing a 200-page novel, or no, 220, let's just go 250. Okay. So here I'm just changing the settings so I can see it a little bit more clearly. So these are their 2 different starting points. And this is the rate at which they're reading the book. Okay. Now, at this point right here, you notice where they intersect? This is when they're at the same spot. So this would be at about 8 days. They're both at page 169, 170. They're about a page 170 at day 8. So she catches up to her after the first week. So guys, after this, you notice she just keeps reading more and more. So by the time we get to 220, which would be somewhere up here, right there. Yeah, she'd be done in about 11 days. So she'll finish the book in 11 days. Would she finish the book? Ooh, just barely. Yeah, she timed it perfectly. So she must have done the math. She'd finish right on time. So they both finish on time. But Mary because she's reading 20 pages a day, once she catches up to her, she reads it way faster. So this is the point where they're at the same spot, but the person that gets to 220 first finishes the book first. So there's page 220, there's 10 days, there's page 220, 13.8 days. So that would be day 14 if you round that. So yeah, this is, remember also we talked about rounding for the test. You want to round it to whole numbers when you're answering these questions. Okay? All right. So those are the answers for that. Last question, solving by approximation. So here, if we graph these, the problem is they don't meet at a perfect spot. So what we're going to do, guys, for approximations, we're going to use Desmos as well. So write down these equations. We're going to go to Desmos. We're going to plug in these equations and figure out where their answer is on Desmos. Because these, unfortunately, if you graph them, it's not going to be a very clear answer. Okay, and I'll show you what I mean once we graph it. So I'm going to go back to Desmos. And I'll type them in Desmos too, so you should copy them. You could copy them there as well. I'm going to delete these. Actually, I'm going to refresh this so it goes back to the original format. Okay, so the first equation I had was 5x minus 4. And the other one I had was y equals negative 6x plus 14. Okay, so there you go. There's the graphs, guys. See how handy this tool is right here? Now, here's what I mean by approximating. If we zoom into this right here, right? This is the point of intersection right there. But you see how the intersection's at decimal points? It's not, the answer is not 2 and 4. That is not where they meet. Because 2, 4 would be over here. That doesn't show up, but this would be 2, 4. So when you're rounding, you have to be careful because the more you round, the less accurate your answer is. So guys, for this one, what I would type as my answer is I would round this probably to the 10th place. So my X answer, I would say, is 1.6. And my Y answer I would put as 4.2. So this is what we mean by approximating. It's not 100% exact, but it's better than just rounding to whole numbers. And actually, the less that you round, the more accurate you are. So if you were to round it like this, 1.64, and the other one was 4.18, that would be even better. So what you have to do whenever you have these approximation answers, read where they want you to round. Do they want you to round to the 10th spot, 100th spot? How many decimal places do they want? Okay? And that's really about it.